Thanks for the introduction, Rick. I do appreciate it. It's always great to be here. Before I get going, I want to thank, and I want to hear a round of applause for the Springfield telescope makers. I know that a lot of us were concerned about the weather New England has had, from May and June and all, and I was worried about how is Stellafane going to be, and is it going to be a hot mess up here? And it's just outstanding the way you guys have kept this, allowed this place to open up in such great shape. So thank you so much. Excellent job. And I also want to thank the people who were selling at the swap tables this morning. I know that some people, perhaps my wife, was concerned I'd be spending a lot of money, but none of you had anything I wanted to buy. So, so thank you so much. All right. So I guess the first question is, why collaborate with professionals? We're all amateur astronomers. We like looking at things. But, honestly, there's only so many times you can look at M13 or the Orion Nebula and see something new. And after a while, it's like, well, why am I doing this? Or it might become, why am I doing this? Maybe you've just been doing astronomy a while and there's professionals and you'd like to somehow help. Help to maintain or grow the knowledge base. Or you might be, like me, a retired person and you got some time on your hands and it's like, well, what more can I do with my life to help out while I'm relaxing? So bottom line is a lot of reasons. But we'll try to give you a couple suggestions. So why do the professionals want to collaborate? There's a lot of professionals. There's a lot of grad students. We have at least one postdoc here tonight from the Space Telescope Science Institute. There's a lot of them. They all need data for research and papers. No papers equals career suicide. Okay? It's publish or perish. And there's only a finite number of big professional telescopes. So they need observations of objects in order to do their research and put papers together. The postdoc I was talking to last night told me that for the Space Telescope, Hubble Space Telescope, one of his co-researchers, has put basically the same proposal in 20 times over 20 years, and it keeps getting rejected. He can't get time for this on Space Telescope. Well, maybe there's ground-based stuff that could help. And they're counting on us for help. So the quickest and easiest way to help out requires no effort on anybody's part here, is to join what's called BOINC at Berkeley, UC Berkeley. So some of you are familiar with SETI at home. It's a similar kind of deal. All you're doing is you're setting up your computer to help research projects when you're not using it. You don't have to interact with it. You don't have to analyze anything. They're just using your CPU cycles. And the whole BOINC project, at one time, I haven't looked at it in the last 6 months, but at one time, when they did an evaluation of all the computers that their software was running on, they effectively had the largest supercomputer in the world doing research for them. It was all because we donated clock cycles from our little laptop to them, which is kind of cool. No effort involved, like I said, and there's a bunch of programs you can contribute to. Some are in molecular biology, protein folding, which is, I guess I know the buzzwords, but I have no idea what it really is. There's some math, cryptography programs they have going, and there's 3 or 4 astronomy projects they have going that are beyond SETI at home. In this unreadable slide, you can see this is a third of the projects they have running that you can choose to help with it or not. There's Einstein at home. Which is an astrophysics thing, cosmology at home, run by University of Illinois. There's an astrophysics program run by the Charles University in Prague, asteroids at home, doing some asteroid research. So there's a lot of different opportunities there that you're contributing time to, but just doing that helps out. The next step up, is, at least as far as I'm concerned, is called Zooniverse. So again, you're using your computer to help out. No telescope, no cameras required, but there's interactive projects that you help out with. They have a series of images of galaxies, and they need people to help classify galaxy types in each of the images. And it's pretty easy. They do the training online, pretty easy to do, and you could do it whenever you like. One project is that the European Space Agency is doing in Zooniverse is called VARI, V-A-R-I, and it helps classify newly discovered variable stars. They have multiple images of variable stars. They give you the brightnesses, how they vary, and using certain templates that they provide, you classify it as Cepheid variable, an RR-Lyra variable, whatever. Again, no specialized equipment required. Now, there's a new one that just came out. It was announced like a week and a half ago, and I've been communicating with Alan Stern about it. And that is the New Horizons amateur collaboration that's going to be going on just next month in September. So they're going to be using the New Horizons spacecraft. I think most of you know that's the one that did the Pluto flyby. Alan Stern came by here a couple times, gave great presentations. They're going to use it to look at Uranus and Neptune. Now, New Horizons is way beyond Uranus and Neptune, so they're going to look at basically the dark side of it, the edge of the atmosphere, if you will. It'll be unilluminated by the sun. And they're looking for amateurs with, they say, 12 inches and larger telescopes that do planetary imaging to simultaneously take images of Uranus and Neptune from the Earth. They want to know if there's any white spots or anything else in the atmosphere that they might be able to see the edges of. If you go to their website, which again is unreadable, but I can give people later on, or you could just do a search on New Horizons amateur collaboration. They tell you exactly what dates and times they're going to be observing, and they'd like amateurs here to observe with them and send them their images. That's kind of cool. If we can help the New Horizons folks, that's a positive. They want amateurs to observe in red, and if they have infrared available, that's good too. But red filter is good enough. So I'm an AAVSO. I've got to mention variable stars. Sorry, Rick. So we do variable star observations. It's very important to the professional world. So variable star research, the data is dependent on, is dependent on star type. It can be used to determine mass, radius, luminosity, composition, and other physical characteristics of the stars. And it doesn't take a lot. Oh, and that's Sir Isaac Newton, that's not Brian May. Are there many variable stars in the sky? This is an inverse image of the Orion Nebula. Orion Nebula is right here. All of the dots up there that are identified are variable stars right around the Orion Nebula. So if you looked at the Orion Nebula in binoculars, you've actually unintentionally observed over 100 variable stars. Okay, so what do you need to image some of these and save the data? You need a digital camera and a computer. Don't really care what kind of camera. It's been demonstrated that for some variable stars, you can use your cell phone and get meaningful data and submit it that it's useful to the professionals. And we have some, AAVSO has like forums, like ask questions, answer questions and such. And there's been people have put in PDFs into those forums about here's how I use my cell phone and got meaningful data. And you could just ask the question, how do I do this? And people would answer you. The EV scopes, the new little automated, tiny little telescopes, which I was running one last night, they've been used for variable star photometry, brightness measurement, and they've been used for exoplanet imaging. It's a very doable thing. But wait, if you become an AAVSO member, and I'll mention that right at the end, how to do that, you get free access, and I did a talk on this last year, to 10 telescope and camera systems worldwide that you can use for free to take images of the variable stars. And we have online analysis tools to help you really painlessly evaluate the data. And that's northern and southern hemisphere. So just because you live in New Hampshire like me, or Massachusetts like Eileen here, or Vermont, sorry Rick, doesn't mean you can't observe stars down towards the southern pole. So Hans Stoffel, there ain't no such thing as a free lunch. Images need to be saved non-compressed. No JPEGs. JPEGs alter the images. You can't get meaningful data off of them. But pretty much all cameras store in RAW, or what's called RAW or FITS formats. So not a big deal. If you use a color camera like a cell phone or a DSLR, you have to actually pick the green from the blue from the red pixels. But there's free software that does that painlessly. So it's not a big deal. Images do need to be calibrated to remove like vignetting. Again, there's free software available to do that. You probably want to use a tracking mount because exposure times could be long. But if you're looking at bright stars, you might not need to. Again, with a cell phone, looking at fourth magnitude stars, you don't need to track. We do offer free manuals, mentorships, and videos, and online forums, including to non-members. You don't have to be, any kind of magical member to get all of our information. Online training classes are held periodically. There is a small fee for those. Another great source on learning to do this kind of stuff is on Cloudy Night's Scientific Amateur Astro Forum. People there talk about variable star observing. They talk about spectroscopy. There was somebody talking about polarization measurements they were doing, polarimetry. It was interesting stuff. Now, a question I've had asked a bunch of times is, okay, I submit some data. Who cares? Does anybody care? Yes, people use your data. One of the things AAVSO does is send out weekly notices of who used your data or accessed your data. So like almost every week, on Saturdays, I get an email that said, a professional or a student or an amateur accessed a data set that included data you contributed. Doesn't tell me exactly who, it doesn't tell me what they're doing, but it shows that somebody's using this stuff, which is kind of cool. Two or three times a month, sometimes even more, researchers reach out to AAVSO and AAVSO reaches out to the membership to follow certain stars at particular times. And a lot of them are people who are using Hubble Space Telescope and now James Webb, and they're looking. So there's like one case would be if they want to observe what's called cataclysmic variables. They're faint for long periods of time, then every now and again increase in brightness 4 or 5 magnitudes, and then go down again. And they're trying to figure out why is this occurring. Well, in a lot of cases, the Hubble Space Telescope will be saturated. The images will be saturated if they get it during a peak. So they want amateurs, right before they observe, to be observing that object, those stars, so they can tell if they should just wave off Hubble. If the telescope is saturated, it's useless, so they'll go on and do something else, and they'll come back later. And they want us to kind of, help them know what's going on before they potentially waste space telescope time, which is really expensive. So we do that 2 or 3 times a month. Okay, and I got to tell you, it's happened over last year or so. There is nothing, as an amateur astronomer, there is nothing cooler than getting an email sent to you from a professional astronomer. I got one from a professor at the University of Leiden in Belgium saying, I see that you're observing a variable star that my team's interested in. Thank you very much. Please keep observing it. We need your data. And oh, by the way, would you observe this star, and this star as well? I mean, you can't help but say, yeah. Okay, so it's really cool. And also, just about a month and a half ago, we had a professional reached out to me and said, thanks for your data. I'm publishing a paper. Here's a draft of it. Do you mind if we list you as a co-author? Now, it hasn't been published yet, so I can't, it might not be accepted. But it's, how do you say, yeah, no? And I had the opportunity to, not that I'm not a professional, I didn't study astrophysics, but I did get an opportunity to read through his draft, and I didn't understand half of it. But I had the opportunity to make corrections if I actually knew anything, which I didn't, which is neat. So I've had both these happen, and I've only been observing for about 4.5 years or so. I now have about 20,000 observations in the variable star database, and none of those observations are made from my home observatory. I'm not set up, I haven't spent the money to do that, to do good variable star work, but I use AAVSO net at next to no cost. And I wake up in the morning and I get an email that says, you have mail? Well, you have images. And I just sign in and there's my images and I do data analysis as I'm drinking my first cup of coffee. And I drink too much coffee. Okay. So AAVSO net, if you remember, just submit a one-page observing proposal. I want to observe this star. Here's where it is. Here's how bright it is. Here's the filters I want to use. And knowledgeable people inside AAVSO basically pick which telescope is best suited to your needs, do the images, and then just send them to you. It's really easy peasy. I've put in 13 proposals. I've had 11 accepted. And the 2 I haven't had accepted were proposals where somebody else is already looking at that star and it would have been redundant. And I just didn't know it at the time. Okay, so I mentioned, so it's AAVSO net is a collection of remote telescopes. We take about 15,000 images per month across the whole network. Again, 10 telescopes, but on any given night, just because of weather, probably 3 are in use. So you might not get data every day. But it's, it's like weather here. One of our telescopes is in New Hampshire, and this year I think we've had 6 clear nights. But the ones in New Mexico were providing data. Now it's like monsoon season and it's not providing data, but the Australian telescopes are providing data. So we have wide field, small, 180 millimeter telescopes, and narrow field, half-meter larger telescopes. And you don't have to do your own calibration of the images. That's automatically done by our servers, in our servers. The cost to users is AAVSO membership. Unlike, and again, not knocking the services, but unlike iTelescope or SLU, where you pay per observing hour, and I think the charges are typically $25 to $100 per hour on their telescopes. It's just AAVSO membership. There's no hourly fee. When I took a look at what my membership fee is and kind of did a back-of-the-envelope calculation of how many observing hours I was using the scopes for, I'm paying about $1 per imaging hour, which is dirt cheap. It's far less than commercial stuff. And it's far less than the cost of my own observatory. We have two system sites. Types, bright star monitors, which are Takahashi Epsilon 180 astrographs. They're on Paramount mounts. The price of each of these systems, if you went out and bought it, is on the order of $50,000. So it's great to be able to whistle them up for free. What we call faint star monitors are 20 or 24-inch instruments, Newtonians, Cassegrains, Dull Kirkhams. Pretty big. Those are on the order of a couple 100,000 if you had to whistle them up. Smaller field of view on the faint star monitors, but they go to magnitude 19 or fainter. So there's pretty much nothing you'll want to observe that these scopes can't see. I mentioned that we're all over the place. There's one up in New Hampshire. North of me, there's several in Arizona, Texas, New Mexico. We have one in Hawaii, and we need some help getting it up and running. If anybody lives in Hawaii or can go to Hawaii on their own time, I think we need polar alignment. And right now, this only shows 2, but there's now 3 in Australia and 1 in New Zealand. We'd like to get one in South Africa, but don't have the funds yet. This is a Takahashi Epsilon 180 on a Paramount mount. Stellafane Gary Walker designed the enclosure. I think we have like 3 or 4 of his enclosures, different places in the world. This is called MPO 61, Madronas Peak Observatory. It's actually near where ATMs of Boston are going for the eclipse trip next year. And that's a 61 centimeter Brachycratienne. My projects, I do a bunch of different oddball things. My favorite star, it's weird having a favorite star, is and it has a really, catchy name, V1117 Hercules. It's what's called an Uxor UX Orionis type variable. It's basically a star with a rotating gas and dust cloud, and the gas and dust cloud is really clumpy, so we can't really forecast on a week-to-week basis its brightness. I'm looking at a couple other stars that are similar. NSV 6690 is interesting, to me at least. A team in China identified this active galactic nucleus that's variable, and they believe it's two black holes closely rotating around each other, and they think within the next year they're going to merge, but they're not sure. So I figured, well, that's something interesting. I'm going to catch the merger of 2 black holes. What's that going to look like? So I'm using one of our scopes to do that. Then I'm also looking at one of the Pleiades stars, Bu Taurus, which is an eruptive irregular variable. One of the neat things about observing variables, which didn't dawn on me until I started doing it in the Pleiades, and it's actually a difficulty, is they're almost all variable stars in the Pleiades. They're all relatively young stars, and young stars tend to be variable, and I had a hard time finding a star of constant magnitude to use as a reference, because like everything in the field of view was variable. And then I saw that nobody was reporting on all these other variables, so I started reporting those too. So from one image, I provide data on 22 variable stars. And I got another X-ray black hole binary, V616 Vulpecula. So oddball things. This is my favorite star, V1117, and you can tell why. So for many years, the open circles mean it was a visual observation. The green circles mean green from a CMOS or CCD sensor, and then red, violet, and blue in near-term years. But anyhow, so it was like, bottom line was like, for a long time, every roughly 400 days, this star dropped in magnitude by like 2.5 to 3 magnitudes. And even that was kind of questionable. Here it went to 14, here it went to 15, here it went to 15.5. So, but roughly every 400 days. But then in like 2019 or so, it started getting more complex. And that's when I started observing it. And here's the last few years. It's just gone crazy. And I've been actually, anytime I meet a professional, I've been trying to talk him into trying to figure out what the heck is going on here. It used to be period was every 400 days. Now, if I look at data in here, some of the minimum to maximum to minimum again are a week. Some of them are 14 days, and I just don't know why. But we're collecting copious amounts of data. As soon as some professional gets interested in it, maybe Andy from Mount Palomar, who's been around Stellafane this weekend, will get interested. I don't know. Exoplanets are another way to contribute. So I'm getting off AAVSO a bit. Exoplanets are another way to contribute. Generally, you have to have CMOS or CCD cameras on either a long telephoto lens or on a telescope. But NASA needs help in verifying the orbits on these things, orbital periods. It's unlike variable stars where I take 8 or 10 images over the course of 10 minutes. These things you need to be able to take hundreds of images over the course of 4 to 6 hours, depending on the variable, in order to get the whole light curve of it. Can be done with small telescopes, can be done just with a camera or a DSLR camera. There are people out there who have done that. And there's a bunch of them everywhere. Another little plug for AAVSO is NASA wanted some organization to maintain a database of exoplanet transits data. And AAVSO reached out to NASA and said, well, we already do variable star database. We can just basically replicate that for exoplanets. Now AAVSO maintains the database for NASA. Oh, okay. So most exoplanets discovered have a close-in large planet. They call them hot Jupiters, so it's a large planet close to it. Some have multiple planets. Some planets orbit their star in a multiple star system. So you got a binary star, and only one of them is known to have an exoplanet. And there's a few planets out there that are free floating, but not many have been discovered. Oddly enough, some planets have orbits that are opposite from the star's rotation, which is kind of interesting. Like when you think about this gas cloud starting to rotate and condense and form a star, you'd think that every part of it would be in the same direction. So the ultimate star rotation would be the same rotation direction as the planets. And they don't know why, but in a few cases they aren't. They aren't. Possible. Again, I'm an observer. I'm not a theoretician, so I don't even play one on TV. So, and a few have planets that are disintegrating around their host star, which might be the case of like Tabby star. Remember that made a hit a few years ago. Some people were thinking it was a Dyson sphere, which would be cool, but we've all read too much Larry Niven science fiction. And studying exoplanets helps us answer, is a planet rocky? Can it support liquid water? Have an atmosphere potentially? And now with James Webb on orbit, they can start actually observing some of these exoplanets and figure out if they do have atmospheres directly. Do the atmosphere contain signatures that give us confidence that life could exist? And the professionals rely on the amateur astronomers and citizen scientists to answer these questions. There aren't enough big telescopes and telescope time available to do everything. And a 12-inch, a 16-inch instrument, I don't know if Mario's around with his 32-inch. There's a guy in Utah with a 72-inch Dobb. You can do a lot with a 72-inch home telescope. The dominant methods do transits. So as the planet rotates around, part of the time it occults the star, and so you get the dips in magnitude. And the slope of the dip gives us information about the size of the planet, potentially about whether it has an atmosphere or not. But we're really looking at duration. Come on. One other thing we could do is actually confirm that transits happen. Some of the test data were glitches. They thought they saw an exoplanet, but as people started observing them, it's like, no, there's no exoplanets there. You had a cosmic ray or something screw up your CCD. Let's kind of go through this. Okay. Another thing to do, getting involved without access to telescopes, is NASA's citizen science programs. Test Planet Hunters, if you go online, you can check that out. Mainly computer-based analysis. NASA's Exoplanet Watch project, deals with confirmed exoplanets, and again, we store the results in the AAVSO's exoplanet database. So then there's this relatively new thing, the unistellar science imaging. I don't know how many of you saw, I'm just up off of the path here. I was playing with a borrowed unistellar telescope last night. So it's a little, 4.5-inch, not even Newtonian, it's a parabolic primary with a CMOS sensor at its prime focus. And you run it from your cell phone. And when it takes images, it goes to your cell phone. But unistellar, so they're automated telescopes for imaging only, run off of your cell phone or Chromebook, and that's it. So the company Unistellar, which is a French company, they fund 4 or 5 astronomers on a part-time basis to find projects for owners of their telescopes. Some are exoplanet observations where their researchers will pick an exoplanet, put a blast out to all their users saying there's going to be a transit forecast at this date at this time. Everybody out there who wants to take images of that exoplanet, that star, during that time interval, send us your images, we'll do the analysis, we'll publish a paper on that exoplanet transit that we've all observed, and oh, by the way, you'll be listed as a co-author. I mean, that's, again, easy peasy and kind of cool. And when you're running one of these telescopes, well, I've demonstrated it from my house, just in testing, I can have this telescope 100 feet away from where I'm sitting with my cell phone running it. So I'm inside watching, Law and Order on TV with my cell phone next to me, and I'm running the telescope outside while it's doing its thing. You don't have to stay out in the mosquitoes and cold. It's almost as good as having a turret telescope, right? You can avoid being outside in winter. You just have to set it up. So anyway, I think that's a kind of a cool system that they have. They do exoplanet work, they do comet observations, they're doing near-Earth orbit asteroid observations. And the observers use your scope, send the data in, the scientists analyze the data, and they write and publish papers using it. I mean, it's really easy peasy. There's downsides. Again, Ton Stoffel, there ain't no such thing as a free lunch. Okay? They're relatively expensive. It's about just over $2,000 each. And they have some size and imaging limitations. It's only a 4.5-inch reflector. Well, what does that mean? Last night in 5 minutes, I was getting images of Stefan's quintet. They weren't great images. I'd have to integrate for an hour to get really nice images. But still, even seeing the quintet, it's a group of galaxies all gravitationally interacting, but even seeing them in 5 minutes in a 4.5-inch telescope is kind of cool. And I was looking at the Saturn Nebula, I think it's one of your planetaries, and in 2 minutes I could see the ring. It's really neat. I think these prices are going to be coming down. There's a company called ZWO, a Chinese company that makes a lot of cameras that people use these days. And at NEAF this year, they introduced a version of this with a 2-inch apochromat as their objective. And a little filter wheel in it, so you could change filters. They introduced that at $400 introductory price, and now they're at $500. But they're not shipping yet. They're 2 months late in shipping their first product. But that's caused Unistellar to immediately offer $600 off. Okay, so they have competition. The writing's on the wall. The prices of these things will be coming down. And again, just like the Unistellar system, the ZWO is all automated. Run it from inside your house. Run it off your cell phone. Have fun. Oh, this is Unistellar's science programs. They have this is some marketing hype a little bit. Planetary defense, what they call that's near-Earth orbit asteroids, exoplanets, comets, far out asteroids, and cosmic cataclysms. Like as soon as M101 showed the supernova, when was that? May was that, or April? Whatever, earlier this year, Unistellar was all over that, and they had people with their automated systems providing data to them so they could plot the supernova. And you can see the supernova in their little telescope. But it's cool. They're doing some good stuff. Now, there's other opportunities as well. I'm going to mention the Center for Backyard Astrophysics. And it's kind of related to Columbia University centric. They're observing particular types of cataclysmic variable stars, and they provide charts where to find them, comparison stars next to them, with suggestions on what stars to observe. They will use your data again and produce papers. So that's kind of a cool group to work with, and they're very interactive. With the amateur community. Kilonova Catcher, that's gravitational wave follow-on observations for University of Paris. Sadly, there aren't many black hole mergers that we could observe, but every now and again. And I'm sure this is basically the end of my talk. I'm sure there's more projects out there I don't know of. If somebody else knows of some other project, please raise your hand and tell us about it. But there are really plenty of opportunities, no matter how lazy you are. Just giving people your CPU time on your laptop to doing significant time for the Center for Backyard Astrophysics people. There's something for everybody. I don't have to go through this. Okay, so we have a special offer. Wait, there's more from AAVSO. So full membership at AAVSO is $95 a year. It does cost a little something to maintain telescopes. We have 5 full-time staff members. We have a budget of around $1 million a year. So we do need income for that. If you're not a member of AAVSO now and you wish to give it a try, from now until 2 weeks from now, if you send this lady, Kathy Spirer, whose email you can't see, an email, we're offering discount memberships of $40 for the first year. Give it a try. If it doesn't pan out for you, you've only wasted $40.
Can you read that email for us?
Yeah, you think I can read? Maybe. Okay, yes, I can read it. So it's KSPIRER, Kathy Spirer, so it's just K and Spirer, at aavso.org. So I think that's the end of my story. Does anybody have any questions? Here. Questions, comments? What did I do wrong?
I'll have something at the end. I've got a very interesting contribution I made to science.
Ooh. Don't be shy.
Hi, folks. There's a lady back there.
Oh, great. That's my daughter.
How competitive are the time slots for AAVSO observing? Like, how many people are looking to use the
So right now, I would say roughly half of the possible observing time we have is being utilized by members' projects. And we actually use the remaining time to do fill-in work, which is just create star catalogs, basically. So we've got tons of time available on all of our telescopes. We are nowhere near maxing out our capabilities.
Here's.
I'm curious, you make it sound so easy. Why aren't these professional astronomers joining and doing what they need to do? What value are you adding in that pipeline?
Okay. I'll give you an example. So some professional wants to observe some star X, okay? They put a proposal in to get time on Mount Palomar or whatever, some big telescope. They're given an hour or two, once every 6 months, maybe, okay? But they want to know what's going on in the meantime. They can count on, and a lot of these things are relatively bright. Relatively bright is, again, 19th magnitude or brighter, right? You don't need Mount Palomar to look at that kind of thing. Honestly, a 3-inch refractor in your backyard can get to magnitude 15. So they need people like us to help them out. And the universities don't have a whole raft of 3-inch refractors. They just have a telescope they get a little time on, and that's it. So they need help with that. There's a lot of objects to follow, and there's only worldwide, I've heard the number, like there's 200 or 250 professional size, and I can't even quantify that, telescopes. But there are thousands and thousands of objects that researchers are interested in. One interesting problem we have is, and this is an internal AAVSO problem, is name recognition. So Thursday at the Hartness House, there was a series of workshops, and I did a presentation there just solely about our network of telescopes and how to use it and how it's constructed and its history and such. And at the end of the presentation, this really surprised me. At the end of the presentation, when we asked for questions, the assistant director of Mount Palomar Observatory was in the audience, and he stood up and said, he's like a 50-something-year-old guy, I'd estimate, really nice guy. He stood up and said, I want to publicly thank you and your organization for what you do. I've relied on your data for years, and you're doing God's work for us. Thank you very much. So the problem we have is we have these middle-aged and older astronomers who are very familiar with us. Well, all of these universities are churning out new grad students every year, and for whatever reason, those kids have never heard of us, so they're not using us and they have no clue. So we're trying to find ways to really reach out to the grad students, because the 60-year-old professionals all know us. So we're trying to find ways to do that. That's an internal issue we have. Ma'am.
So, question and comment. First, there's no such thing as too much coffee. Second,
Well, I'm zooming here, so maybe there is.
so let's say you're like me and you live in a Portal 9. Can we participate with this program?
Absolutely. You could do regular astrophotography from that. Is Wayne here this year? Do you know? Wayne Zool?
Wayne Zool, I don't believe so.
So the Springfield telescope makers have a member, the guy's name is Wayne Zool. He lives 17 miles from Manhattan, okay, in New Jersey, obviously. It'd be that or the Atlantic Ocean. And he does some of the best wide field deep sky photography I've seen. And the way he does it is he utilizes narrowband filters, right? So he's observing with a hydrogen alpha filter, and the street lights and all don't put out very much on that wavelength, if anything, at that wavelength. And O3 and I should know S2. And this is with a DSLR camera and a telephoto lens predominantly. Or he just puts a light pollution filter in front of the lens, and that blocks off like 90% of the light pollution. And he does some pretty spectacular work. It can be done. I'm in the Amateur Telescope Makers of Boston, and we have a member named Sal Laricchia, who is in Somerville, Mass. He can see downtown Boston from his house, and he had the attitudes like, oh my God, it's so bright, I can't do deep sky, I'm only going to do planetary, I'm only going to do planetary. And then just this year, he's like, well, I'm going to try deep sky with filters. And he's getting outstanding results. It's doable. Although all of us would rather be in the Mount Katahdin, dark sky site. But you can do it. You can. Even if it's just cell phone photography, you could buy a filter and tape it in front of the camera on your cell phone. Sean Walker from Sky and Telescope, he lives in southern New Hampshire. He was showing me images this morning that he took just from his cell phone, unprocessed, up here last night. And the Milky Way was spectacular. A 30-second exposure on a cell phone. You just don't handhold it. You gotta, lean it against something. Cell phones can do good work. And in a light polluted area, just put a light pollution filter in front of the camera. Anytime. Anything else? Yeah.
Where would somebody find out more about what goes on in stars? I mean, I have a basic science background, but not no astronomy. But I need more than just like public information.
Sure.
I need to go deeper, but where?
Oy,
Without grad school.
Sky and Telescope, or even Astronomy Magazine would be good for that. They publish a fair number of papers on the physics, if you will, of different types of stars and other things in the sky, black holes, neutron stars, et cetera, et cetera. That's a good site. Eileen?
AAVSO courses on stellar classification.
Yeah, there's AAVSO has courses on how to classify various kinds of variable stars, but not so much into the physics of really why they're, what's going on. Another nice, pretty reasonable site, and a place you could just ask questions of if you want, without, or look at other people's threads, is if you go to Cloudy Nights. Are you familiar with Cloudy Nights? Yes, okay. Cloudy Nights, go to the scientific something astronomy forum. Just a scientific astronomy forum. It's like, in my laptop, it's four screens down. And there people talk about all kinds of different things about astrophysics and stellar atmospheres and doing spectroscopy and showing their results. That's a pretty good site.
But seriously, the magazines, I learned in my college days, I was a physics major, but I also went upstairs to the astronomy department. And even so, and I took an astronomy course, but even so, I learned an awful lot from Sky and Telescope, and even the Observer, that is the Astronomical League Observer magazine, which is now very well produced and has very good articles in it. You'll learn a lot by using those sources.
Oh, also, nowadays, hey, I sound like such an old timer. If you go to edx.org, 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 that's a series, so that's an online resource that links you up to online college classes in everything. If you want to take a class in astrophysics, which is, I guess that'd be classified as that, you can sign up. It's free. Okay, in my case, I've done some of that stuff. I understand half of what's going on. Okay, I still learned something. And a lot of them are basic, and a lot of the classes are more advanced. You can kind of pick and choose. And they have classes in everything. When my daughter, back there, wave Anna, right? When she went to the University of Rochester and finally decided to be a software engineer, took her a while. It took her a semester. When she finally decided to do that and said, okay, she's going to do software. I haven't taken a computer course since 1978. It's like, I got to show that I have some chops in that. So I took an online Python course. It's a computer language. And I passed it. So I said, okay, I can do this computer science stuff too. Just the easy ones up. But there's a lot of online courses offered, and they're all free. And they're offered by MIT, Harvard. I took one, University of Texas at San Antonio. I can't remember the big university in Israel that does scientific stuff. They offer, University of Melbourne in Florida has courses up. They're worldwide courses from universities worldwide.
Gentlemen.
Yes.
I read a biography of Richard Feynman, and his younger sister wanted to learn some science. Back then, girls don't study science. So he bought her a freshman level physics book at MIT. understand it.
Right.
She went on to become a physicist.
Very cool. Yeah.
The lady here was looking for college level things. I believe that, although I haven't gone to the site, the Astrophysical Journal has gone open source, so you no longer have to pay $1,200 a year for the subscription. And you cannot dive deeper into the deep end than going to them. If you want math and you want complications, it is the place to go.
Definitely true.
I think we've been offered a variety of sources and ideas to learn everything from the very beginning, like reading the reflector and maybe sky and telescope, all the way to subscribing to the APJ without having to pay for it anymore. That's a great idea. I have a quick story. I think I made a contribution to science, to professional science. When I was in graduate school, I was a member of the Delaware Valley Amateur Astronomers, and we went out to a country site away from Philadelphia to observe once in a while on special schedules. I had a young high school friend that I took with me in my car, and we went out and observed with his C8 and so forth. He later went to Villanova University and studied astronomy, and he now, still today, this was like 50 years ago, not 50, but 40 some years ago that I did this with him. He still works for the Space Telescope Science Institute. He helped the people deconvolve the faulty images and make them sharp when they first had the Hubble telescope without the eyeglasses that some of our members helped to build. So I think I made a contribution to science by actually contributing a scientist. Anyway, thank you, Peter. I think it's almost noon. We can have a few more questions, and then it will be lunch hour, and there will be another talk at 1 o'clock. Any more questions, just quick, before Peter gets a chance to have lunch?